In this video, I'll be going through the question you see on the screen here from the 2023 Leaving Cert Higher Level Maths Paper 2. If you're looking for a different question from this paper, check out the description below. There should be a playlist there. And if you're looking for a different paper entirely, have a look around on my channel. I'll be doing all this on a whiteboard, hopefully like you're used to your teacher doing. But we are on YouTube, so take advantage of the features there. Watch it at half speed or double speed, and certainly pause and try the question first. If you find this video or any of my videos useful, I would greatly appreciate a like or subscribe, but what helps especially is sharing it with a friend that might be doing the Leaving Cert this year or next. Question 6 starts off with just a simple question. Well, not simple, but they're trying to trick you, by the way. They give you this statement: two angles are vertically opposite if and only if they are equal in size. Is this true or not? What's your justification? First of all, they're asking, do you know what vertically opposite means? Vertically opposite is when you have this situation across, and this angle here, A, must equal this angle. Or indeed, this angle, B, must equal this angle. That's vertically opposite. So if you were trying to prove something, you'd say, well, B equals this angle because they're vertically opposite. So is this statement true? Two angles are vertically opposite if and only if they are equal in size. Lots of students would answer yes, but it's a classic trick that you do need to keep an eye out, not just in maths but in life. You're being proven something the wrong way around. No, if two angles are equal, that does not mean they are vertically opposite. Here's a isosceles triangle. Let's say these two angles are, 80 and 80. That would leave 20 up here. These two angles are equal. They have nothing to do with being vertically opposite. So no, they're just trying to trick you here with the wrong way around. This statement would be true the other way. Well, not the other way, but if I wrote this statement, if the if was out front here, if two angles are vertically opposite, then they are equal in size. That's true. But if you move the if to the other way, because turn this sentence around and say, if two angles are equal, they are vertically opposite. No, here's two more angles that are equal. 30 degrees, and this one unrelated 30 degrees over here. They have nothing to do with each other. So, and that would answer the question. Just say false and give an example of something that's not vertically opposite. That's fine. Or some of the English I said would also work. Okay, in B part 1, they want us to prove that FE, this length here, is equal to EH. And they give us some help. They tell us to use similar triangles. So I'm thinking about this triangle up here, this FED triangle, and I'm thinking about this one, DE and H triangle, and they want us to prove these two numbers here. Let's call it X for now. Well, they want us to show that these are both X, I guess is one way to say it. How do we go about doing that? What we need to do is we need to show 3 parts of this triangle are equal to 3 parts of this triangle. That would mean they're similar. For example, this length here, let's see, that's a D or no? ED is equal to ED, and we just write something like same. That's proof of one and one of them at least. And the next one, I would try and prove that this angle here is equal this angle here. But how do I go about doing that? I know this angle is theta, but what is this angle here? And the secret would be that this angle is the same as this, because they're alternate. They're alternate angles in a two parallel lines with a line across it. They're alternate angles. So I'd write something like, let's see, I'd write something like EHD is equal to CBD. So that's EHD, this angle, CBD, this angle. And I'd tell them why. I'd say alternate or something. That's be fine for the examiner. And then I would say, EFD, I hate writing out all this to be honest. EFD, this angle, must equal the one we want, EHD, because they're I guess both theta. So I've just shown that EHD here is equal to this guy, and this guy was theta, so they're both equal to theta. EFD was, they told us it was theta. They're both theta. Okay, I have, let's see, this is equal. I have this being equal to this. Just one more. You can look around yourself, different places. What I found anyway, is, let's see, this angle in here and this angle, they're vertically opposite, the one we just did before. Whereas we're also this angle, so let's write that out, BDC, this angle is equal to 90 minus theta. Because it's this is 90, they all add up to 180, so that must be 90 minus theta. Yeah? And then this angle in here, let's put these as double dots, all of them, because they're actually all equal. This angle in here, FDE, there's lots of different ways to get to this, by the way. FDE also equals 90 minus theta. So that means they're equal to each other. And, HDE. And let's go over here. Let's assume this was all one page going down. HDE must equal CDB, because they are opposite. They're opposite angles to each other, and therefore that means these two equal each other. Because what have we got here? HDE must equal then FDE. I guess I should write that one down. HDE equals FDE. So these are the two angles again, and that's three of them. That's this one equals this equals that. That means all three equal each other. So we can say these triangles are the same. FED, maybe a whole triangle out here, must equal the whole triangle of EHD. And if that's true, then this length must equal this length. FE must equal EH. I'm sorry that's all messy. I hate doing these. I hate teaching these. They're very easy to do yourself, just to go, oh, well, that's because of that, that's because of that. It's hard to tell the examiner. And unfortunately, you do have to tell the examiner what you're doing. This angle equals this angle, and why. The examiner, I think, would give me full marks, but they might not, because I'm very messy doing it. Just do a bit of practice. There's lots of examples. Be slow at this. It's going to take a few minutes writing all this, double checking you get all the right angles everywhere. Anyway, that's the answer to part one. There's a part two still. In part two, they want us to find theta. What is theta? And they tell us hence or otherwise. That's usually a clue that the fact that these two are equal should help us. And that's where I will start. I'll think, why these two being equal help me? And I look at this strip across. These are parallel lines. Mine don't look parallel. This length is 20. That means up here must be 20. So I can straight away know that FE equals 10. I don't have to write all these letters this time, thankfully. I know this is 10. And that means I know that little triangle in there is 10 and theta. And that's I want theta, I have a right angle. I'm just missing a bit of information, but it's getting me somewhere. But hopefully you notice that a lot of these angles are all the same. These are this triangle and this one down here. That's this one here. Is what's that? 30 and theta. It's not similar. It's not congruent. Yeah, I made a mistake in the last question, didn't I? I said similar over and over. These are congruent, they're identical. These two are similar though, in fact. They have the same angle, the same right angle, and we proved earlier that these two angles equal. We put a double dot on them. These are similar. So if we rewrite these two triangles so they sort of look the same, this one being 10, if I invert it and rotate, it'd be 10, it'd be a right angle, it'll be theta. If we just name these two sides, x and y, I can use the same tan formula on both. Tan of theta on this one would equal y over 30. And tan of theta, let me write it out again. Tan of theta would equal x over 10. Well, tan of theta equals itself. I think you'll agree. So that means y over 30 equals, I'm just thinking there might be a simpler way to have done this. Still, we get a formula here for y and x. Y is equal to 3x's. So whatever x is, y is 3 of them. Now that helps because look at these two triangles on top of each other. This is x here and this is y. They add up to get 90. So x plus y equals 90. And we also know that y is equal to 3x's. That's 4x's equals 90. X must equal, what is that? 22.5. Put that back in and we can just solve for theta. We have it here again. Tan of theta is equal to 22.5 over 10. So, put that into a calculator and solve it. We will get theta is to the nearest degree is 66 degrees. Okay, that's question 6. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.